tracing, we are going to find a length of the curve. That is the topic. Rectification means finding length of the arc of the curve given in Cartesian, polar or parametric form. So there are certain formulas based on this. So if you consider the equation y is equal to f of x, this is Cartesian equation. Explicitly in terms of x, y is equal to f of x, and s is the arc length being measured from a x1 y1 to b x2 y2. Then we use formula s arc length x1 to x2 integration root of 1 plus dy by dx bracket square into dx. Similarly, if it is given in terms of y, x is equal to f of y, s being measured again from a x1 y1 to b x2 y2. Then s is equal to y1 to y2 root of 1 plus dx by dy bracket square into dy. So these two formulas used for the Cartesian curve. Y is equal to f of x and x is equal to f of y. Similarly, if you are having polar curve, r is equal to f of theta and s is the arc length being measured between the polar coordinates r1 theta 1 to r2 theta 2. Then s arc length, it is given by theta 1 to theta 2 root of r square plus dr by d theta bracket square into d theta. And next one explicitly in terms of r, then and s being measured from these 2 points p r1 theta 1 and q r2 theta 2. Then s is given by r1 to r2 root of 1 plus r square d theta by dr bracket square into dr with respect to r, here with respect to theta. Similarly, last one, if you are having the parametric equation. So these are parametric equations of the curve. X is equal to f1t, y is equal to f2t, where t is parameter and s being measured between 2 points a t1 and b t2. Then s is given by the formula a t1 to b t2 integration root of dx by dt bracket square plus dy by dt bracket square into dt. So these are the formulae used to find arc length for Cartesian, 2 formulas, 2 for polar and 1 for parametric. Now let us see some illustrated examples on this. First example, find length of the arc of the circle x square plus y square is equal to a square located in first quadrant. Now if you observe this problem, to find arc length in first quadrant means positive quadrant. Now if you observe here, so x square plus y square is circle with center at 0 0 and radius is a. So this is standard circle. So this is circle a. Okay, so this is origin and this is x-axis, this is y-axis, so this is center. Now I have to find this length. Now coordinates at this point, it is a0, coordinates of this point 0a. So x from 0 to a you can take, or x from a to 0, y from 0 to a you can take it here. These are the coordinates. So this length we have to find out. So we have to find this length in the first quadrant or positive quadrant. Now we use the formula x square plus y square is equal to a square. So this is point A, this is point B. S, this formula for this S is, you can take X or you can take Y, it does not make any difference there. X1 to X2, root of 1 plus, this is Cartesian equation. So I take this formula, dy by dx bracket square into dx. Now as x varies from a to 0, so I take, this is x coordinates, this is 0. Okay, so I take x from 0 to a, root of 1 plus dy by dx bracket square. Now I find dy by dx for this into dx. Now this equation I can write down y is equal to root of a square minus x square in the positive quadrant, or directly also you can differentiate. So dy by dx for this is, dy by dx for this, from this equation, this is equal to 1 upon 2 times root of a square minus x square into minus 2 times x. So this 2 gets cancelled. So I put this value over here and simplify. So x from 0 to a, root of 1 plus dy by dx bracket square. Bracket square means you are getting this as x square divided by a square minus x square into dx. So I just take the LCM, x from 0 to a, root of a square minus x square plus x square divided by root of a square minus x square. So here plus x square minus x square gets cancelled. You are getting this as 0 to a, it is a divided by root of a square minus x square into dx. I just take the limits should be taken as a to 0, not 0 to a, because a to 0, so a to 0. So I just take the limits a to 0, or we take the absolute value finally, even if you take 0 to a. So I simplify this, this is equal to a, and I take the integration of this, this is sine inverse x upon a, limits applied a to 0, a to 0. So this is equal to a sine inverse 0, a 0 minus sine inverse 1, sine inverse 1, sine inverse a upon a, it is 1, so it is pi by 2. So pi a divided by, this is equal to a inside the bracket minus pi by 2, so minus pi a divided by 2, so length is positive, so we take the absolute value pi a divided by 2. So it will be, so this is length intercepted in the positive quadrant. Now if you, this problem can be solved by polar coordinates also. Suppose you would like to use the polar coordinates, then we just transform this equation into polar coordinates. X square plus y square is r square is equal to a square, means r is equal to a is the polar equation of the circle. So r is equal to f of theta, I am using r is equal to f of theta. So s is equal to theta 1 to theta 2, root of 1 plus r square plus dr by d theta bracket square into d theta. So I put the values here and get theta varies from, theta is equal to 0, this line, and this here it is theta is equal to pi by 2. So it's the same limit you are getting, theta from 0 to pi by 2, root of r square means it is naturally a square, and dr by d theta, You try to find out this dr by d theta. This would be 0. So it is 0 here into d theta. So we'll get this as a theta from 0 to pi by 2 into a d theta. So integration of this, it is a theta limits applied 0 to pi by 2. So you are getting this as pi a divided by 2. So similarly, you can solve this problem by parametric also. The answer would be same. If you take in the exam, you need to solve by any one of the method there. So in the parametric form, if I take x is equal to a cos t and y is equal to a sin t as parametric equation of the circle. So formula used, dx by dt I will write down. It is minus a sin t and dy by dt, it is a cos t, derivative of this a cos t, and t varies from, again at this particular point t is equal to 0, here t is equal to pi by 2, so t varies from 0 to pi by 2. So these are the limits for this parameter. So s varies, s formula, it is a t1 to b t2 root of dx by dt bracket square, dx by dt bracket square plus dy by dt bracket square into dt. So we put the values here. T varies from 0 to pi by 2 root of dx by dt bracket square a square sin square t plus a square cos square t. I take it from here, a square cos square t into dt. So I take a square common, means under outside the radical sign it is a, t varies from 0 to pi by 2, and here sin square t plus cos square t, that is 1 actually. So you are getting this as a 0 to pi by 2 into dt. So this is equal to a, t varies, integration for this it is t, limits applied 0 to pi by 2. So you are getting this as a pi by 2. So if you observe this problem for finding length of the arc in the positive quadrant, you can use either Cartesian or polar or parametric, answer would be same. So this is the way of effective use of this 5 formulas there for finding arc length in Cartesian or polar or parametric form. Now we go for the next example. Second sum on this, find arc length of the curve r is equal to a 1 plus cos theta located above initial line theta is equal to 0. Now this is polar curve. This is of the form r is equal to f of theta. So this is polar curve. Solution for this, how to find out arc length? We use formula for polar curve. R is equal to d1, equation of curve, r is equal to a 1 plus cos theta. This is cardioid, symmetrical about initial line theta is equal to 0, because theta is equal to 0, r is equal to 2 times a. So dr by d theta I will find out for this. Dr by d theta would be a, differential of 1 is 0 minus sin theta. So this is minus a sin theta. And shape of this particular curve would be something like this. So if you observe, it is this theta is equal to 0, r is equal to 2 times a, and this would be something like this. Theta is equal to 0, theta is equal to pi by 2, theta is equal to pi, theta is equal to pi, and here r is equal to 0. How much time is left? 15 minutes. Okay. So we need to find this length which is lying above the initial line. Theta is equal to 0. Theta is equal to 0. So let us see how to find out this length. So this length I have to find out. This is which is lying above the initial line. Theta is equal to 0. Which is lying above the initial line. Theta is equal to 0. So what to do with this? The formula used, it is S is equal to theta 1 to theta 2. For the polar curve, the formula is r square plus dr by d theta bracket square into d theta. This formula we are using. So I put the limits. Now how to find out limits for this, for the initial line? So this point is, for this curve, theta is equal to 0, and this length we need, so theta is equal to pi. So it ends here, it starts here, so theta is equal to 0 to pi. I have to put the limits. So theta is equal to 0 to theta is equal to pi root of r square. R square means a square. I put the value there. A square 1 plus cos theta bracket square plus dr by d theta. Readily we obtain here. It is minus a sin theta. I put this value here. Minus a sin theta bracket square into d theta. I simplify this. Theta from 0 to pi. I simplify this. I take this a square outside, means a outside here, root of, and outside the radical sign. I open this bracket. It is 1 plus 2 times cos theta plus cos square theta plus sin square theta into d theta. Sin square theta plus cos square theta, it is 1. So 1 plus 1 is 2 actually. So you are getting theta from 0 to pi root of 2 plus 2 cos theta d theta, or this is equal to a 0 to pi. I take root 2 outside here. So root 2 into a theta from 0 to pi root of 1 plus cos theta. 1 plus cos theta d theta. Now I integrate this. So integration of this is equal to root 2, s is equal to root 2 into a, theta is equal to 0 to pi, 1 plus cos theta, it is root of 2 times cos square theta by 2 into d theta. This root 2 and root 2, it is 2. So 2 times a, theta from 0 to pi cos of theta by 2. Cos of theta by 2 into d theta. I take the integration. This is equal to 2 times a, integration of this, sin theta by 2 divided by 1 by 2, and limits applied 0 to pi. So this 2 means it becomes 4 times a inside the bracket, upper limit minus lower limit we apply. So sin pi by 2 minus sin 0. So you are getting sin pi by 2 1, sin 0 0, means it is 1 minus 0 is 1. So you are getting s, that is length of the arc of the caridoid, which is located above the initial line. It is 4 times a. So this is the way you can use this polar length of the arc in polar coordinates. Now similarly, Suppose you are having the problem like this. Find the length of the parabola. Problem number 3, or we take one parametric equation. Find length of the arc. Find length of the arc. Length of the arc of the curve x is equal to e raised to theta cos theta, y is equal to e raised to theta sin theta, from theta is equal to 0 to theta is equal to pi by 2, where theta is parameter. These are parametric equations, though it is theta. So these are parametric equation of some curve. Solution for this. So parametric equations means theta is parameter. Theta is parameter. So formula used, given x is equal to e raised to theta cos theta, y is equal to e raised to theta sin theta. So I find dx by d theta or dx by dt. Dx by d theta, this is equal to e raised to theta cos theta u into v cos theta minus e raised to theta into sin theta. dy by d theta would be dy by d theta. This is equal to e raised to theta sin theta and plus u into v. You are using first function constant, differentiation of second constant, differentiation of first, sin theta e raised to theta into cos theta. Now theta limits given here 0 and pi by 2. So the formula we are using for the parametric curve, s is equal to theta 1 to theta 2. Now root of dx by d theta bracket dx by d theta bracket square plus dy by d theta bracket square into d theta. So this formula we are using for the parametric. Theta is parameter. So I put these values here. So substituting this dx by d theta in this equation, these values of differentiation, these expressions for differentiations, s is equal to theta, it is given limits 0 to pi by 2, root of dx by d theta bracket square e raised to theta cos theta minus e raised to theta sin theta bracket square plus e raised to theta sin theta plus e raised to theta cos theta second derivative bracket square into d theta. I just take e raised to theta outside here. Theta varies from 0 to pi by 2 and open the bracket. From e raised to theta, I just take it outside. So e raised to theta outside, root of, here opening this, cos square theta minus 2 times sin theta cos theta plus sin square theta. Now second bracket, e raised to theta is already taken out. Square means e raised to 2 times theta, outside the sin it is e raised to theta plus sin square theta plus 2 times sin theta cos theta plus cos square theta into d theta. Now this gets cancelled and what is left is here cos square theta plus sin square theta, it is 1, sin square theta plus cos square theta, under the radical sign it is 1, 1 plus 1 is 2 there. So you are getting theta from 0 to pi by 2 e raised to theta and here it is root 2 into d theta. So I am getting this root 2 outside, integration of e raised to theta is e raised to theta and limits I am going to apply 0 to pi by 2. So this is S actually. So this implies S is equal to root 2 upper limit e raised to pi by 2 minus e raised to 0. It is 1. So S, it is root 2 e raised to pi by 2 minus 1. So this is arc length of this parametric curve from theta is equal to 0 to theta is equal to pi by 2. So the next example on rectification is find the arc length of the parabola y square is equal to 4x from vertex to one extremity of the lattice rectum. So this parabola, if you observe here, y square is equal to 4x. It is drawn here with vertex at origin, and 4a is the length of the lattice rectum. So this point is a minus 2 times a. So we have to find out this length from O to point A, from vertex to one extremity end point of the lattice rectum. So this length we have to find out up to this. So x varies from 0 to a, y varies from 0 to 2 times a if you take the limits accordingly. Now y square is equal to 4x, we differentiate, we find dy by dx. Y square is equal to 4x, 2y, dy by dx is the derivative with respect to x. 4a, x is 1, so dy by dx 2a upon y. Now I consider the formula s is equal to y1 to y2 root of 1 plus dx by dy bracket square into dy. Now what I do here, take the limits y 0 to 2 times a, y coordinate 0, y coordinate 2 times a, root of 1 plus dx by dy. So here dy by dx, we take its reciprocal y upon 2 times a bracket square into dy. Now we simplify this. I take 2 times a square root. It is 4 times a square. It is outside. So 1 upon 2 times a. I take the LCM, 4a square plus y square into dy. Now 1 upon 2 times a outside. Now integration of this is y by 2 using this formula. Integration of root of x square plus a square dx. This is equal to x by 2 root of x square plus a square or y square plus a square by 2 log of x plus root of x square plus a square. This formula I am using of the integration. So I am getting this as a is equal to, it is 2 times a. So I use y by 2 root of 4a square plus y square, 4a square by 2 log of y plus root of 4a square plus y square or 4a y square plus 4 times a square. Limits applied 0 to 2 times a. I apply upper limit, y is replaced by upper limit 2 times a, then 4a square, here 4a square by 2, it is 2a square in fact. So y log of 2a is here 4a square plus 4a square, it is root a square, minus for the lower limit this term would be 0 and this term will left remaining there, it is 2a square, log of it is 0 and here 0 means log of root of 4a square. Now if you simplify this, you are getting in this particular form here, a, this means 2 root 2a square, here 2a square, and I just take 2a square outside and use the formula log a minus log b, it is 2a plus root of 8a square divided by a. So a gets cancelled. So this on simplification, a root 2 plus log of 1 plus root 2, that is arc length being measured from origin to the one extremity of the lattice rectum, it is this. Similarly, we shall see some more examples of this. Next example, 5, some polar form, find arc length of, arc length of r is equal to a, the curve e raised to m theta, r is equal to a e raised to m theta, intercepted between r1 and r2, intercepted between r1 and r2. So r1 and r2. So this curve, it is spiral of Archimedes. This standard curve given r is equal to a e raised to m times theta. So limits for r is equal to r1 to r is equal to r2. So to find out this length, so dr by d theta, this would be a m e raised to m theta with respect to theta. Then I replace this is by a, it is m into r, because r into a into e raised to m theta I can replace for this. So I use the formula, this is dr by d theta. So formula used is naturally for theta is equal to f of r. So that formula is s is equal to r1 to r2 we need. So it is root of 1 plus r square d theta by dr bracket square into dr. This formula we are using. So I put it here, s is equal to r1 to r2 root of r square 1 plus r square d theta by dr. dr by d theta is this, so d theta by dr naturally it is 1 upon mr. So taking the reciprocal, 1 upon mr bracket square into dr. So I simplify this, this is equal to r1 to r2 root of 1 plus r square divided by m square r square into dr. R square gets cancelled. So I am getting this on simplification, r1 to r2, 1 plus, I just take the LCM, m square plus 1 divided by m square into dr. So this is constant, so I take it outside the sign of integration, m square plus 1 upon m, and limits r is equal to r1 to r2 into dr. So this is equal to root of m square plus 1 upon m, and integration of this, it is r, limits applied r1 to r2 for r. So s is equal to root of m square plus 1 divided by m into r2 minus r1. So this is arc length of this spiral. It is located between r is equal to r1 to r is equal to r2. Now next curve is sixth one. Find arc length of asteroid x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. Find total length of the asteroid x raised to 2 by 3, y raised to 2 by 3, a raised to 2 by 3. So this is standard curve actually. This is asteroid, means star shaped curve. This is star shaped curve. So if you observe this curve, it is something parametric equations for this we taking parametric equations for this curve. Parametric means that for that parameter the equation this must be satisfied. Parametric equations, that is x is equal to a cos cube t, y is equal to a sin cube t, or theta you can take there t, where t is parameter. T is parameter by which this equation is satisfied. T is parameter, and shape of this particular curve is for x is equal to 0, y is equal to a, and for y is equal to 0, x is equal to a. This is x-axis, this is y-axis. So this point is a0, this point is 0a, and here is the cusp at this particular point. Here is the cusp. It is something like this curve. If you try to trace, it would be something like this. So cusp at 4 points. This is origin, this is A, this is A, this is minus A, this is minus A. So this is asteroid star-shaped curve. You need to find total length of this curve. Total length. So I just find out this length and make it 4 times in the first quadrant. This is the length, and I make it 4 times. T varies from, I take the parametric equations, T varies from 0 to T is equal to pi by 2. At this particular point, you can check out for T is equal to 0, T is equal to 0 to T is equal to pi by 2. At A0, if you observe, x is equal to a, x is equal to cos t is equal to 1 means t is equal to 0, y is equal to 0, sin t 0 means t is pi by 2. So at this particular point a0, t 0, similarly 0a if you are taking, then t is equal to pi by 2. So t varies from 0 to pi by 2 for this. So we use the formula in the parametric form. That formula is S is equal to T1 to T2 root of parametric dx by dt bracket square S. So this is in first one plus dy by dt bracket square into dt. So total length is equal to 4 times S. We find out S and make it 4 times. So the parametric equations given, it is x is equal to a cos cube t, y is equal to a sin cube t. So you have to find dy by dx by dt and dy by dt. Dx by dt, this is equal to 3 times dx by dt, this is equal to 3 times a cos square t into minus sin t, derivative of cos t, it is minus sin t, and dy by dt, it is 3 times a sin square t into derivative of sin t is cos t. So I put this in this particular expression. I may be calling this is 1. So S is equal to, therefore S, this formula we are using, t from 0 to pi by 2 root of, I put the values dx by dt, it is 3 times a minus 3 times a cos square t into sin t bracket square plus dy by dt means 3 times a sin square t cos t in bracket square into dt. So we simplify this. So I just take this constant outside. 9a square. 9a square means outside, it is 3 times a. Outside the radical sign, t is equal to 0 to pi by 2, and root of, you are getting this as cos raised to 4t sine square t plus sine raised to 4t cos square t dt. So I'm getting this as 3 times a. T varies from 0 to pi by 2 limits, and I take sine square, root sine square cos square means sine t cos t, it is outside, and inside the radical sign you are getting cos square t plus sine square t into dt. So this is 1, this is 1, so root of 1 is 1, so we'll get 3 times a. T varies from 0 to pi by 2 sine t cos t dt. I integrate this, I multiply and divide by 2 to use the half angles. So 3a by 2, t varies from 0 to pi by 2, and this is sine of 2 times t dt. I integrate this, this is equal to 3a divided by 2, and integration of this minus cos of 2 times t divided by 2, limits applied 0 to pi by 2, and this one minus 3a divided by 4, 3a divided by 4 inside the bracket. If I apply the limits, pi by 2 means cos pi, it is minus 1, minus cos 0, it is 1. So you are getting this as, this is 6a minus 6a divided by 4, minus minus plus, in fact I'm sorry, this is 3a divided by 2 and multiplied by 4, so this is length in the first quadrant or positive quadrant. So total length, it is multiplied by total length of the asteroid, means this plus this plus this plus this. So total length, this is equal to 4 times, yes, I put the value of s. S would be 3 times a divided by 2. 3 times a divided by 2 means it is 6 times a. This is length of this curve.